Hello students, welcome to another short video on our Small Steps Good Grades Secondary Science program. Today we are going to do organic chemistry on alcohols, and I have summarized some important pointers in this short video, so let's go. First, what is the functional group of alcohol? Meaning when you see this specific group of atoms or bond in the compound, you will know, aha, this is alcohol. So the functional group is OH functional group with a single bond here, yeah? And they are actually non-hydrocarbons because they contain carbon, hydrogen, and oxygen. So if the compound only contains carbon and hydrogen, like our alkanes and alkenes, they are our hydrocarbons. Most of them are volatile liquids at room temperature and pressure. And if you forget what is a volatile liquid, means they evaporate at low temperature, meaning they have a very low boiling point. Most of them are soluble in water, yeah? Solubility decreases with increased molecular mass and size, meaning as it goes down the homologous series, the molecule gets bigger, then it is less soluble in water. The general formula is CnH2n plus 1 OH, where N is the number of carbon atoms. So for instance, you will have C2H5OH. Please note that the H, there are two H here, and when you see a total number of 6 hydrogen, you should write C2H5OH. Similar to the alkanes and alkenes, each member of the alcohol homologous series differ from the next by a CH2 unit. Wow, what is all this? My bad. So basically, we are going to go through some common reactions of alcohols group. We have our combustion and oxidation. For oxidation, alcohols is easily oxidized by the oxygen in the air, or when we heat them up with oxidizing agent like potassium manganate and potassium dichromate. And also remember the color change. Potassium dichromate, it changes from orange to green, and for potassium manganate, it changes from purple to colorless. For this color change, if you are still confused and you need some visual presentation, please refer to my redox micro video where I will show you in laboratory how acidified potassium dichromate changes from orange to green and how potassium manganate changes from purple to colorless. For combustion, it is exothermic, just like any other combustion. And how is combustion of alcohols useful? Alcohols is a cleaner fuel, as it does not produce pollutants like sulfur dioxide. Now, what will produce sulfur dioxide? When we combust or when we burn our fossil fuel. It is also a renewable fuel, as it can be manufactured naturally by just fermenting our, grapes, and we can also make ethanol artificially by the hydration of ethene. All right. For the chemical reaction, read your question properly and ask yourself whether it is complete or incomplete combustion. The question says that it is in an enclosed small room. It is referring to insufficient oxygen, hence incomplete combustion. So alcohol burned in excess air to produce carbon dioxide and water for complete combustion. Incomplete combustion will produce carbon monoxide and water. For our pure chemistry students, we have 2 more alcohols reactions to study, which is dehydration. And let's go through dehydration first. The conditions needed is 170 degrees Celsius, and we use concentrated sulfuric acid in excess. All right. So dehydration is the opposite of hydration of ethene or hydration of alkene. So what will we get? We will get an example is you use ethanol, you dehydrate it, we will get ethene plus water. The other reaction will be esterification, which you use the acid plus alcohol, you'll get ester and water. The conditions will be concentrated sulfuric acid, and we have to heat it to warm the mixture. Now, do take note for these two conditions, both uses concentrated sulfuric acid. So it's a good reminder to tell you, oh, for reactions of alcohol, the common condition reagent is concentrated sulfuric acid. We only use dilute sulfuric acid to acidify our oxidizing agent, all right? An example will be butanol plus ethanoic acid. You will have butyl ethanoate plus water. Regarding the naming of ester, it is covered in another micro lesson. Manufacturing of alcohol. For this homologous series of alcohols, we need to study the two ways of manufacturing our alcohols. So the first way is hydration of ethene. And mainly when we talk about manufacturing alcohols, we are actually talking about manufacturing ethanol, because ethanol is widely used. So the first one is hydration of ethene. The second one is the fermentation of carbohydrates. And you have to know the uses of ethanol in alcoholic drinks, as a fuel, and we talk about it being a cleaner and a renewable fuel compared to our fossil fuel, right? In the previous slide. So as a fuel, it's used to power motor vehicles and also used in cooking. And it is widely used as a solvent in paint, varnishes, deodorants, perfumes. For the hydration of ethene, the conditions will be 300 degrees Celsius, 65 atm pressure, phosphoric acid as a catalyst, all right? Ethene can be obtained from catalytic cracking of petroleum. So petroleum is our fossil fuel from the ground. So this is the chemical reaction, ethene plus water. Under this condition, we will have ethanol. Not renewable. Why? Because petroleum is a non-renewable source. All right? Too, however, is less time consuming than fermentation. Fermentation of carbohydrates. Now, the conditions needed will be water, sugar, yeast, darkness, and the absence of oxygen at 37 degrees Celsius. It is a chemical process in which the yeast will act on the carbohydrates to produce ethanol and carbon dioxide. So you have simple glucose here, leading to ethanol and carbon dioxide. Why is the temperature kept at 37 degrees Celsius? Answer: enzyme in the yeast will denature at high temperature above 37 degrees Celsius. All right, then we don't have yeast to act on the carbohydrates to produce ethanol and carbon dioxide if it is at higher temperature than 37 degrees Celsius. Question: why fermentation of sugar takes place in absence of oxygen? So when there is absence of oxygen, there will be anaerobic respiration. Only during anaerobic respiration, the end products will include ethanol. In the presence of oxygen, water and carbon dioxide will be formed instead, just like our normal products from respiration. Then why must fermentation be in the dark? Because this lactic bacteria that do the work of fermentation flourishes in the dark, and light actually kills them. All right. For the three questions here, question 1 and 2 are often seen in exams, practices, but I do see some exams asking on why fermentation needs to be in the dark too, but it's not really a common question. Lastly, we have the comparison table between the hydration of ethene and fermentation. For the time, hydration of ethene is definitely shorter, fermentation will be much longer. It takes about 3 weeks. The percentage yield for hydration of ethene, it can actually go towards 100% if you add excess water. However, for fermentation, it's only about 15%. For both process, ethanol is produced, and the hydration of ethene is costly. However, it is more cost-effective than fermentation. Fermentation is very time-consuming, and it's hence less cost-effective. The last comparison will be for hydration of ethene. It is non-renewable. Why? As I have mentioned earlier, ethenes come from the catalytic cracking of crude oil, and crude oil is a non-renewable source of energy. For fermentation, is renewable sources because the glucose comes from our plants, like our grapes and our sugarcane. All right, so that's it. I hope this short video blesses you. Rewatch them until you are familiar and memorize the conditions and the reactions of alcohol. I see you in the next video. Adios.